Hello students, my name is Ashwini Kumar. I am from David Jalandhar. Today I am going to give you a lecture on numerical solutions of differential equations. Now, after single step methods, we have next category, multi-step methods. So again, uh, why? This why is very important. When you have whys, you can learn better, right? So my opinion is always ask your teacher questions. Always ask the doubts, right? So again, multi-step methods. Why we need multi-step methods when we have Runge-Kutta method, when we have other methods as well? So the answer is accuracy. So we need more accurate results, right? So you have seen in Runge-Kutta category, we have only evaluated the value of yi plus 1 by considering the values of xi and yi. So no previous value, no previous step value we have involved in the solution. Now if we involve the previous step values as in our solution, we will get the more accurate results. So this is done by the multi-step methods category. So let us learn. We have mainly two multi-step methods. One is Milne's method and another one is Bashforth method. Now you can see one term here written, predictor corrector. What is that? When we solve multi-step methods, when we uh, find calculations over these methods, we always have two steps. In one step, we will predict the value, and in another step, we will correct that predicted value. So that's why this category you can see, this category is known as predictor corrector method, right? So see, predictor corrector methods. So multi-step methods are predictor corrector methods, right? We have two methods, Milne's and Bashforth methods. Milne predictor corrector method. So these are the formulae for predictor and corrector by Milne's technique, right? So you can see here, not only yi, we are using yi minus 1, yi minus 2 as well as yi minus 3. That means for evaluation of yi plus 1, we need 4 step values. See, at the step I minus 1, at the step I, at the step I minus 2, and for the step I minus 3. So previous 4 step values we are taking to evaluate the value of yi plus 1, right? So after finding this predicted value, you see, we will substitute this value, predicted value, in our formula here. See, right? So we will substitute this predicted value in this corrector formula to enhance the accuracy, to make our result more accurate. So that's why these multi-step methods works in two steps. One is prediction and another one is correction, right? So this is one example by Milne's method. Here we have given slope y dash equal to x plus y, and we have given the previous 4 step values. This is our y naught, say suppose x naught, this is our x naught, this is x1, x2 and x3, right? Now see y2, if you just see your table, what is h? You can tell me. Yes, you are correct, h is 0.5. Now see yourself, 0, 0.5, 1, 1.5, the next value should be 2, right? So if you assume 2 as your y4, right, then these values are x0, x1, x2 and x3. So at the points x0, x1, x2 and x3, the values of y are given y0, y1, y2 and y3. So we will use predictor corrector method, Milne's predictor corrector method, to find the value of y4. So as we have learned, we have learned that we first predict the value and then we will correct the value. So this is your prediction first of all, prediction formula. Now see, this is your prediction formula. We just replace n by 3, right? So if we replace n by 3, we will get y4p is equals to y0 plus this formula. Now all these values which you have given in your table, you just substitute all these values here. This is your y dash, right? You will substitute x0 y0 to get y0 dash, x1 y1 to get y1 dash, x2 y2 to get y2 dash, right? These are the values. See, you will substitute x0 y0 to get y0 dash. To get y1 dash, you will substitute the values x1 y1. To get xy2 dash, you will substitute x2 y2. To get x3 y3 dash, you will substitute x3 and y3. So all these values, when you substitute, you will get the values of y0 dash, y1 dash, y2 dash and y3 dash. So substitute all these values here, you will get the desired predicted value, right? So after predicting the value, now we have to correct the value. So see, after substituting all these values in the formula, we have found the predicted value. This is our prediction, right? Now after this prediction, we will substitute this value here. This y4 we will substitute here, right? So again y4 dash is as per your given slope x4 plus y4. So we will substitute x4 plus and y4 in our slope, we will get y4 dash. So after getting y4 dash, we substitute the values here. So you can see, we can find the results. This is our solution now. So this is your corrected value, right? Now if you want to improve the accuracy, if you need that, say suppose you have some system in which you want more accurate values, what you can do? You can resubstitute this value of y, this y2 means y4. You can resubstitute this value of y4 in your corrector formula to get more accurate values. You will get more accurate values, right? Next method we have Adam-Bashforth predictor corrector technique. In this technique, the formulas are very similar to Milne's predictor corrector, just the differences of formulae, right? In this method, we have predictor formula as this and corrector formula as this. So only problem you will face to learn this formula, because coefficients are very large, right? Nothing else. This is very similar to Milne's method, just the difference is of formula. Yes, one more difference is the accuracy. Accuracy of this method is very, you can say, very good. So one example, in the similar way, in the previous example, as we have done in previous example. So again, I have taken the same problem, same example here, which we have learned in the previous Milne's method, right? So same example I have taken to compare the results. So see, again, same cheese. X0 given, x1 given, x2 given, x3 is given, and y0, y1, y2, y3 is given to us. So again, in the very similar way, we predicted the value of y4 by applying the Adam-Bashforth technique. We have calculated y0 dash, y1 dash, y2 dash, y3 dash. So after finding all these values, we substituted the values in the Adam-Bashforth technique. This become our prediction. So this become our prediction of fourth y4, right? So after getting predicted value, we will correct the value with the help of correction technique. So this is correction technique of Adam-Bashforth formula. So just substitute your predicted value here, you will get the corrected value. Now see the results. This is your y2, this is your y2, this is 1 minute. This is your y2 with the help of Adam Bashforth. Now let us see. Just remember 11.7656, and this is your value by Milne's method, 11.7659. So very less, difference is very less, but the difference is more accurate, right, as compared to Milne's method. You can compare the results with exact method also, right? So these are all methods to solve differential equations, ordinary differential equations, right? So uh, one more category we have, partial differential equations. So I will put one more video for that, and guys, subscribe my channel and like and follow. Thank you.